Hello everyone. Today we shall have a look at the Floyd Warshall algorithm to find the shortest distance between every pair of vertices in a given weighted network. The algorithm is known as all-pair shortest path algorithm. And how is it different from the other already known shortest path algorithm is that, for example, Dijkstra's algorithm or even Bellman-Ford algorithm, they provide the shortest path from a particular source vertex to every other vertex in the network. Whereas this algorithm, as mentioned earlier, will provide us with the shortest path between every pair of vertices. It has multiple names, like it is known as Floyd Warshall algorithm, roy-floyd algorithm, or even roy-warshall algorithm. It is because of the fact that although the currently used version was given by Robert Floyd in the year 1965, the earlier versions were given by Bernard Roy in 1959 and Stephen Warshall in the year 1962, which were used to find the transitive closure of a given graph. Also, we need to note that it only provides the shortest distance between any pair of vertices, but not the path details. A slight modification will also give the path details, and for that we shall use something known as successor matrix, which we shall be seeing with our example. Now we'll consider this network, which has 5 vertices and 7 directed edges. Each of these edges have been given a weight. The weights can be positive or negative, but in this case we've only considered edges with positive weights. As mentioned, we'll have distance matrix dk and successor matrix sk, and we will see what each of those entries will be. The initial distance matrix we denote by d0, and it will have entry 0 if I is equal to j. That is, all the diagonal entries will be 0 because there will be no shortest path between a vertex to itself. And the entry will have the weight of the edge if there is a directed edge from one particular vertex to another. For example, A to B, the weight is 2, so the entry would be 2. Similarly, for A to D, there is no directed edge, so there will not be any entry. Instead, we enter infinity. What about the successor matrix? Initial entry of the successor matrix will be for each node pair I, j, the respective end node j, that is, the respective column head will be given at each of the columns. We'll see how the initial matrices will look. This is the distance matrix. As mentioned, let's say we will take D to C. We have the entry 1. Here D to C we have edge with weight 1, so the entry is 1. Similarly, let's say for B to A there exists no directed edge, so we have entered infinity. And each of the entries in the coming iterations, that is, number of iterations would be equal to the number of nodes. Here we have 5 vertices, so 5 iterations, and each of the entry will be the minimum of the entry of the previous matrix and the sum of the entries of the matrix with an intermediate node in between. When we have a look at the example here, we will get a clearer picture. And as mentioned earlier, the successor matrix will have its initial entry as the respective end node j. This will be the S0 matrix, that is successor matrix with the 0th iteration. Each of the columns will have the column heads themselves unless the entry is infinity in the distance matrix. Now, we'll see, this is the example. Iteration 1 will be the indirect paths via intermediate node A. Intermediate node A. So this will be the distance matrix, and since we will not be finding any shortest paths through A for the edges that involve A, we will call it a pivot row or pivot column. So we will keep them as it is without any change. Similarly, for iteration 2, the second node will be the pivot column and the pivot row. Now, all the diagonals will be 0, as mentioned earlier, no change in that. We will see what will be the entry for B, C. So the entry would be the minimum of the previous entry of B, C. Previously there was entry 6, the entry of B, A plus A, C. B, A is 0, A, C is infinity. Sorry, B, A is infinity and A, C is infinity. So 6 is lesser than infinity. So the minimum of 6, infinity would be 6 itself. So the entry remains as it is. Now we'll see what would be the entry for B, D. It would be minimum of previously entered B, D plus, or minimum of previously entered B, D or B, A plus A, D. So B, D earlier had the entry of infinity. which we should check if there is any lesser value available. So b comma a is infinity plus a comma d is infinity. So there won't be any change. It will continue to be infinity. So I will just enter all the values. Here we can see c comma b would be 7. Then c comma d would be infinity again. Then c comma e would be infinity again. Then d comma b would be infinity again. Then d comma c would be 1, no change again. Then d comma e would be 3, no change again. Here we have e comma b. I think there is a change. Let's just have a look. E comma b, the previous entry of e comma b was 4, which is minimum 4, or e comma a plus a comma b. E comma a is 1 here, a comma b is 2. We have to take the minimum of 4 comma 1 plus 2, which means it is 3. 3 is minimum, so this is a new entry. This is a changed entry. And now rest of the entries will continue to remain as it is. This will be infinity. This will be infinity. I have just shown that here. See, d b comma c is minimum of d naught of b comma c comma d naught of b comma a plus d naught of a comma 6. That will be this. Next, further we have these entries as it is. I have already entered them. 6, 7, 1, 3, 3. Next, what about the successor matrix? Successor matrix will look something like this. Here we have made a change. Instead of 4, earlier entered value was 4. Instead, right now we got 3, which means the intermediate node will be the new entry. The intermediate node that we have considered right now is node A. So that will be our new entry, which is A. So this is our new successor matrix, D1 and S1. Similarly, we go about with the next iteration where the intermediate paths are via intermediate node B. So this will be our second iteration, and our entries here a comma c, it is the minimum of previously entered a comma c, which was infinity. Earlier our a comma c was infinity, which is minimum infinity, or a comma b plus b comma c. We have to check. A comma b is 2, b comma c is 6. So 2 plus 6 is 8. Infinity or 8, which is minimum, 8 is minimum. So our entry would be 8. We have a changed entry there, and then the next entries in this case will remain as it is. We will see that there is one more change in this case where there is e comma c, which is smaller. Earlier e comma c had value infinity. Now e comma b is 3 plus b comma c is 6. 3 plus 6 is 9, which is a smaller value. So we have a new entry there. Then we have infinity again, which is no change. So there will be changes in the successor matrix where we saw changes in the distance matrix, that is 8 and 9. Instead of C, which was there earlier, we put B, since B is the intermediate node right now. Yes, this will be our new successor matrix as well as the distance matrix S2 and D2 respectively, and we see that there are changes in these two entries 8 and 9. Rest of the entries remain as it is. That's why we got changes in the successor matrix as well. We entered the intermediate node value B comma B and B. Further, we'll go to the next iteration, that is the intermediate paths via the indirect paths via the intermediate node C. For this, we have the distance matrix like this. Now C has become the pivot column and the pivot row. We will see what happens to the other entries. We can solve them one by one. I already have the solved entries. This continues to be infinity. Even this continues to be infinity. Next we have b comma a, which is again infinity, and b comma d would be infinity again. B comma e is also infinity. D comma a is infinity again. I think there would be a change with d comma b, so let's have a look. Our previous entry for d comma b was infinity. Now we'll see the minimum value. D comma b earlier was infinity. Now we'll see d comma c plus c comma b. D comma c is nothing but 1. C comma b is 7. 1 plus 7 is 8, which is a lesser value than infinity. So our entry will change to 8. Rest of the entries will continue to remain as it was earlier. This is 1, this is 3, and this is infinity. So we saw one change, that is 8 instead of infinity. So there the successor matrix will change. Here our intermediate node is C. So this entry would become C. This is after iteration 3. Next we have iteration 4, which is the indirect paths via intermediate node D. We can note that there are no edges coming into D. There are only edges going out of D. So there is no way that D will be an intermediate vertex, because for a vertex to be intermediate there should be an edge coming in as well as there should be an edge going out. Hence the matrix will remain as it is, as it was there earlier. Although I have marked the pivot row and the pivot column, it will not make any difference. It will just continue to be as it was. Next we have the final iteration, indirect paths via the intermediate node E. We will see whether there are any changes. There are a couple of changes in this matrix. All these entries will continue to remain as it is. We have 2, 8, infinity. Here E is the pivot row and pivot column, we can see already. Then we have infinity. Then here 6 continues to remain as it is, infinity continues to remain as it is. Next we have CA, which is again infinity. Next we have CB, which had entry 7, so 7 continues to be as it is. Then we have entry CD. CD would have entry infinity. Then we have DA. DA is entry 4. It is the minimum. Earlier we had entry infinity. Now when we took the minimum, it became 4. And DB also, earlier it had an entry of 8. Now we took the minimum and it became entry of 6. Then we have 1. So there are 2 changes in the distance matrix. So there will be change in the successor matrix as well. Now these are the final entries of the distance matrix as well as the successor matrix. We can see that the sum of the entries will continue to be infinity, which means that there exists no path in the directed graph. Since the graph is directed, it is possible that there is no path at all from a particular vertex to another vertex. For example, if we consider from C to A, you can see that there are no directed paths. C to B we can go, but from B we cannot reach A. So C to A continues to be infinite. And we can notice that the entire entry of the column D is infinity, because there is, as I mentioned earlier, there are no in degree vertices at all to D. And how to study the successor matrix? For example, let us consider E to C. E to C, the entry is B, which means to reach from E to C via a shortest path, it has to go through B. So E to C, it has to go through B. At the same time, we can see that to reach B from E, it has to go via A. E to B, it has entry A. So to reach from E to C, it has to go via B, whereas to reach from E to B, it has to go via A. So the path will be E to A to B, and A to C in order to reach from E to C, and its weight is 1 plus 2 plus 6, which is 9. Let's check with the distance matrix if that entry is correct. E to C, the entry is 9, which is correct. That is how we read the successor matrix. So this is about Floyd Warshall algorithm. This distance matrix is a result of the algorithm, whereas the successor matrix is a small extension of the algorithm. So this is how we find the shortest path from any pair, from any vertex to any other vertex in a given weighted network. Thank you.